Algebra 3, quarterfinal review for lessons 1 through 20. Okay. All right. The questions, you guys should have the document in front of you. We're going to start off with question number 20, or not question number 20, but question number 2, as was picked from most needed to least needed. First question is, how many liters of a 76% glycol solution must be added to 69 liters of a 33% glycol solution to get 61% glycol solution? Okay, so what we don't know, we have a percent. So these are a matter of percent times amount. So I know that I've got percent 76. So we always convert our percentages to decimals. Do I know how much of a 76% I'm going to have? No. So what do we use when we don't know? We use X. All right? And it's going to be added to. So I'm going to use addition. And then 69 liters of a 33% glycol solution. So how do I write that? No, not 69 first. Right? It is percent times amount. So percent is what? 0.33. And am I going to use a variable or a number? Number. What's the number? Okay. And so this should equal something. What percentage should it equal? 0.61. What is the amount that it should equal? All right, it's going to be a complex amount, right? Because I've got an unknown amount that I'm going to add to a known amount. So what is that? X plus 69. Okay. So all this, now that I know how to set it up, right, that's the hardest part to this, because the rest of this is just solve for X, correct? All right, so 0.76X is just that. I can't simplify that. Can I simplify 0.33 times 69? Yeah, what is that? 22.77? Is that right? Okay, 22.77. Okay, come over here. What do I do with the 0.61? Distribute. I got 0.61x plus what? 42.09. Okay. Now we're still just solving for x. Right? What I would do, because I want my numbers to be positive as long as I can keep them positive, is which x value should I move? The 0.61 or the 0.76? 0.61. So I'm going to subtract 0.61x, correct, from both sides. Right? And because, again, I want to isolate my variable, I'm going to subtract 22.77 from both sides. Okay, so first off, what's 0.76 minus 0.61? 0.15x equals, and what's 42.09 minus 22.77? 19.32. What do I want to do to solve for x? Divide by 0.15 on both sides. X equals, what is 19.32 divided by 0.15? 128. I think it says, does it say to the nearest tenth? Maybe it doesn't actually say, but we're going to say 128.8 liters. Do I need a variable, or do I need a label? Yes. Okay, I got to have a label. Okay, 128.8 liters. All right, that was number 2. It's a good question. It's one that people are likely to struggle on. Is it super duper difficult to solve? No. I just want to think about percent times amount equals percent amount. Now, forget different types of equations, but that's the general form of that. Number 15. Okay, number 15. All right, number 15 gives me a circle with a square inside of it. Okay, something to this effect. Okay, I've got it shaded around here. Okay. Okay, got OM, O, and point M. Okay. It says OM is perpendicular. It does say OM equals 5, so I can go ahead and put that right there. That is 5. We want to find the area of the shaded region. Well, this is what I want you to know and understand. The shaded region is the area of the circle minus the area of the square, correct? So let's get to that first so that we understand circle minus square is going to be the general form of the equation. Now I do need to find the area of a circle. How do I find the area of a circle? Pi r squared. So that tells me I'm going to need to find radius minus square, which is side squared, correct? All right. Now, do I already know what the area of the square is going to be? Sure. What's the area of the square going to be? 25? No. 100. Because I got to keep going with that line, right? So OM is getting me halfway, right? So if half of it is 5, the whole distance is 10, and 10 times 10 is 100, right? So we know our square is 100. Now I have to find the radius of my circle. So this is what we're going to do. We're going to take this point, and we're going to go to a point on the circle, okay? We're going to make that line right there, which forms a right triangle here, correct? Now, if OM is perpendicular to my line here, what do I know that this line right there is going to be? That's got to be 5 as well, which means I have a 45, 45, 90 right triangle. So I could do one of two things. Either I could do the Pythagorean theorem where I do 5 squared plus 5 squared, right, equals c squared. I'm getting 25 plus 25 is 50, square root of 50, and getting that. Or I can use my 45, 45, 90 special right triangle ratios, which would be 1, 1, radical 2, right? So if it's 5, 5, it's going to be 5 radical 2. So I would get pi times 5 radical 2 squared. Does that make sense? And if I got the square root of 50, it would simplify to 5 radical 5. Does that make sense, or do you need to see that? We're good. All right. So I'm going to go ahead and try to simplify this, because I can simplify 5 radical 2 squared. That is 5 squared, which is 25. And square root of 2 times square root of 2 is 2. So I got 25 times 2, which is what? 50. 50 pi minus 100. Okay, I can't simplify that any further, so I should get 50 pi minus 100. And are they giving me any kind of units? Doesn't look like it. So I'm going to say units squared. Let's look at some answer on 15. And they do get a decimal answer for that. So if you take 50 pi minus 100, that'll also give you 57.08. Okay? I would accept either of these two answers. Does that make sense? The one on the left is exact. The one on the right is an estimate. Unless they tell you, to put it in a specific form, I'll take multiple forms so long as they are equivalent and reduced. Right? If you gave me this right here, I'm going to count off half because it's not reduced. Okay? All right. Let's see. After 15 is number 11. Number 11. So that's giving me 3x over yz plus 2z over x over y over x minus x over z. Okay, let's look at work on number 11. Make sure I'm not messing anything up here. Okay. All right. So you've got fractions on top. You got fractions on the bottom. In order to combine or add or subtract fractions, I got to have or common denominator, right? Okay, common denominator on my numerator is xyz, correct? Okay. So this is going to be times x over x. This is going to be times yz over yz. Okay. All right, I'm going to go ahead and kind of bring some of that. That's going to give me 3x squared plus 2yz squared all over xyz. Is that correct? Take a look at it. Make sure that makes sense. Okay. All right. Then I'm going to have another division bar, and I'm going to try to do this down here. What's my common denominator there? Zx. So I'm going to multiply z over z, x over x. That's going to give me yz minus x squared all over xz, correct? Okay. So the next thing that I have to do is, because I've got a fraction divided by a fraction, can I divide by a fraction? Multiply by the reciprocal. So I'm going to multiply the upper numerator by the lower denominator and the upper denominator by the lower numerator. Ugh. Okay. So I'm taking 3x squared times xz. That's going to give me 3x cubed z. Does that make sense? I'm distributing the xz to both terms, right? Plus, I'm going to have 2. I'm going to have x. I'm going to have y. I'm going to have z cubed. Does this make sense? Okay, you're with me so far, okay? All right, now we're going to distribute the xyz to the yz minus x squared, right? Okay, so I'm going to have x. Let's see, then we're going to get y squared, z squared. Is that correct? Okay. Minus x cubed yz. All right. And before you consider us as being done here, let's see. I want to check. We should be able to. I've got 3 x's there, 1x here, 1x here, and an x, 3 x's there. So can I factor anything out of every term? I can factor out how many x's? I should be able to factor out all of them have a maximum of 1x. Okay, so I'm going to be able to take out, let's go ahead and consider, we're going to take out x to the first. Do all of them have a y? No. Do all of them have at least one z? Yes, so we're going to take out x to the first, z to the first. Okay? All right, so that's going to leave me with 3 what? 3x squared, because I'm taking out 1x, and I'm going to take out 1z, correct? So I'm just getting 3x squared, correct? Plus 2. Okay? I've taken out an x. I'm not taking out any y's. Z what? Z squared. Okay? Let's move down to our denominator. Taking out 1x, does that leave me with any x's? Not taking out any y's. And taking out how many z's? So I'm left with 1z minus, okay, x squared, y, no z. This is my answer. Okay? Do not forget to factor. Okay? You know what I mean by factor, right? Taking out that x and z. Okay, there's a lot going on there, but the process is still the same old steps. Okay? Common denominator, multiply by the reciprocal, factor out. Okay, questions on 11? No? Okay, 12. 12. Now, if I don't get through all of this, is me sending you pictures of these notes, is that going to work for you? Because I probably won't get through all of this. 12. Okay? Is 2xy cubed to the negative third times 2xy squared over xy squared. Okay? All right. Let's see. This is going to give me, let's do this. Because this is all over negative 3, right? We're going to drop everything below the division bar. Does that make sense? Okay. So that's going to give me 2 cubed x cubed y to the 9th. Does that make sense? Okay. Is there any part of that that we don't understand? Okay, I'm going to go ahead and I'm going to turn that 2 cubed into what? Anybody know? 8. And make it an 8. Okay, times, so we got this, times, all right, that's going to give me what in the numerator? 4x, okay, 4x squared y to the 4th over x squared y squared. Can I simplify my fraction on the right? Yeah. What happens to my x squareds? Cancel. All right. So, and I'm going to get, what happens to the y's? Is I probably want to move that one up, right? Right? Okay. All right. So I should be getting 4y what? 4y squared. So I can actually change this to be 4y squared over 1, correct? All right, now I want to multiply. All right, so I'm getting 4y squared over 8 x cubed y to the 9th. Can I simplify that? 4 divided by 8 is going to be 1/2, correct? All right, so I know I'm going to have a 2 on the bottom. What am I going to do with that y squared? Bring it down. All right, so I still have an x cubed down here, and I'm going to get y to the 7th. All right, let's see, what number was this? Number 12. Let's see if my answer is right. 1 over 2x cubed y to the 7th. That's the answer we want. Questions? No? Got it? Simple? Maybe not. Go ahead. What's 4 divided by 8? It's 1/2, right? So my coefficients come to be 1/2. All right. Do you understand that the x cubed is still just x cubed? Okay, because there was no x up there to change anything. So it was just the 2 that you were curious about? Okay. Yep. All right, that's number 12. Number 13. 13, word problem. The sum of the digits of a two-digit counting number is 9. When the digits are reversed, the number is 45 greater than the original number. So we're looking for numbers that add up to 9. We want the smaller number plus the larger number, because whenever I flip them, I should get bigger numbers, right? So we're starting off, I would say 1 plus 8, right? 2 plus 7. 3 plus 6. 4 plus 5, right? Okay, so all of these equal 9. But this number, the numbers are 18, 27, 36, 45. Do we understand that? Okay, so the reverse of the number, okay, the reverse of these numbers are 81, 72, 63, and 54, right? Okay. So what they're saying is that whenever I reverse the numbers, the new number is 45 greater than the original number. So I would say 81 minus 18 and see what that is. 72 minus 27, see what that is. 63 minus 36, see what that is. And 54 minus 45 to see what that is. The one that equals 45, it says when the digits are reversed, the number is 45 greater than the original number. The original number is going to be one of these. Okay, that's what they're looking for, is one of those 4 numbers. All right, what's 81 minus 18? What? 63. What's 72 minus 27? 45. I'm done. The answer is 27. Do we understand how to do that? Okay, I'm sure that there's a formula for doing it, but to me, this is more straightforward. Do we understand? Okay. Do you want to learn the formula? Okay. I think this is way easier than the formula. 14. 14. A parasailer is flying at the end of a straight cord that has a length of 150 feet. The cord makes an angle of makes an angle of 50 degrees with the ground. How high above the ground is the parasailer? I don't know if you've ever seen parasailers, but basically here's a boat. Here's a here's a rope. Okay. Here is a parachute. Okay. So that's what we're looking at. Okay. Now we're going to assume that the water level, is right there. Okay. I know that's not exactly how it works, but we're making a right triangle. Okay. It says it makes an angle of 50 degrees with the ground. So there's your 50 degrees. It tells me the length of the rope was 150 feet, right? Yes? All right, so it goes from there to there. We want to know how high above should be water, I guess, parasailing. You can do it with vehicles, but I wouldn't suggest it. Okay. All right, so we're looking for x in this case. All right, what does x represent according to my angle? Opposite. What does 150 represent? Which trig function uses opposite and hypotenuse? Sine. So we have sine. What do I put after my trig function? 50 equals x over 150. If I want to solve for x, what do I need to do to both sides? Multiply by 150. What do I need to make sure that my calculator is in before I type in 150 sine 50? Make sure it's in degree mode. 150 sine 50 comes out to what? 114. I got 0.91. Anybody else get 9.1 or did we get 8.8? Is that what you said? Did somebody say 8.8? Okay, it should be 9.1, I think, feet. Does that work for us? To me, if you understand the picture, then you'll understand how to set it up. Can't hardly do it without drawing a picture. Yes?
When you tell us, you don't know what the object is, I didn't know what it was, that's why I got it wrong.
You didn't know what the object was?
Yeah.
Parasail. It's probably going to be pretty much the same question on the test. Okay? Okay? And you always have the ability, whenever you're taking your review, if you don't understand a question, to email me and say, hey, I don't understand the question. Right? And I'll email you back. All right, let's see. We're back to what? Question number 1. Okay, question number 1. Draw the necessary reference triangle and evaluate. Do not use a calculator. So it starts off with 1/2 cosine 60. So you have to draw a 30, 60, 90 triangle. Okay, does that make sense? What goes opposite of 30? If you don't know your ratios, you won't be able to solve the question. Okay, because I won't give you credit if all I see is equals. Okay, I need to see the reference triangle. That's your work. What goes opposite of 30? 1. What goes opposite of your hypotenuse? 2. What goes opposite of 60? Radical 3. Okay, so I got 1/2 times, it says cosine 60. What does cosine represent? Adjacent over hypotenuse. Good. So what is adjacent to 60? 1. What is hypotenuse? What's 1/2 times 1/2? 1/4. Can I use my calculator to check and see? And my calculator, if I've done it right, will show me 0.25. But if you don't show me the triangle and the work, no credit. Okay? Okay? All right, let's see. The next part is B, radical 3, tan 30. Can I still use this reference triangle? Yes. Yes. Okay. So radical 3, tangent is what? Opposite over adjacent. All right, what's opposite to 30? 1. What's adjacent to 30? Radical 3. Okay, so I'm getting radical 3, which equals 1. Okay, finally, I have 6 sine 45. Do I need to draw a new triangle? Okay, 45, 45, 90. What are my ratios? Okay. All right, 1, radical 2. What is sine? Opposite over hypotenuse. What is opposite to 45? 1. What is hypotenuse? Okay, so that's going to give me 6 over radical 2, correct? What do I need to do to rationalize the denominator? Not on both sides, on top and bottom. Okay, so I should get 6 radical 2 over 2, and I'm not done yet. No, you don't multiply by the conjugate. Not on, because I have to do it to the top and bottom, because radical 2 over radical 2 equals 1. So I haven't changed the value, right? I don't want to change the value of the fraction. But if I only multiply it by radical 2 on top, what I'm saying is I'm multiplying it by radical 2 over 1. I've changed the value. Okay? 6 radical 2 divided by 2 is 3 radical 2. All right? 3 radical 2 is equal to 6 over radical 2. But 6 radical 2 over radical 2 is not equal to 3 radical 2. Do you see what I'm saying? You do understand? Okay, good. All right, so my answer is 3 radical 2. I'm not going to leave it as 6 over radical 2. Okay? And I'm not going to leave it as 6 radical 2 over 2 because it's unreduced. Right? You need to reduce it whenever you can. Yes. And if you miss one of them, you get half off. You miss 2 of them, it's all wrong. Okay? All right. Number 3. Number 3. I've got time here. This might be the last one I can do. I'm going to do this one verbally. So listen. Huh? It's a proof. So LM is parallel to OP. That's given. Angle L is congruent to angle O because 2 parallel lines cut by a transversal have corresponding angles congruent. You could also say the corresponding angles postulate. Okay. MN is parallel to PQ. That's given. You could have listed that earlier. Angle N is congruent to angle Q. 2 parallel lines cut by a transversal have corresponding angles congruent. Angle M is congruent to angle P because if I have 2 angles, then I have 3 angles. Triangle LMN is similar, not congruent, but similar to triangle OPQ through the angle similarity postulate. That is the answer to that. Does that make sense? Okay. All right. Let's see. I can still get another one in here. 9. Yins vary directly. So yins vary directly as jades squared. Okay, so it's just that. It's direct and I'm sorry. Yangs and inversely as jade squared, and I have to have a k there. Okay, so there's 15 yins. Okay, 90 k and 6 jades, so that's 6 squared. So I got 15 equals 90k over 36. Cross multiply and divide, so 15 times 36 divided by 90. It's going to tell me that k equals on number 9. If I can get there. Let's see. Your k should be 6. Okay, once I have k, they're going to ask me for yins equals. And they're going to tell me that my yangs, let's see, 64 times 6 divided by 4 squared. Right, when we simplify that all the way down, we got 64 times 6 over 4 squared. Let me get back to my answer here. You should get yins equal 24. All right, does that make sense? Careful. Yeah, it's a lot of Y's. Okay, that's pretty much where I'm going to have to stop. We covered 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. 9 of them, and I will take pictures of the rest of my notes and send those out to you here fairly shortly. Okay? All right, let's stop there.